There is a moment that comes for every civilization. A moment when the broadcasts stop, when the satellites fall silent, when whatever stood for centuries begins to grind back into the dust it was built from. And in the deep history of this galaxy, that moment has come for civilizations we will never know existed. They rose somewhere. They built something. They asked the same questions we are asking now. And then they vanished. Completely. Permanently. Without a trace that we could ever detect from where we stand. The Milky Way contains over 400 billion stars. It has existed for nearly 13.6 billion years. Even by the most conservative estimates, intelligent civilizations should have arisen thousands of times across that history. And yet when we point our telescopes outward, we hear nothing. The galaxy is silent. The math of the cosmos and the math of biology say it should not be. So something is happening. Something is filtering intelligence out of the galaxy at a rate so consistent, so thorough, that the silence is not an accident. It is a pattern. Tonight, we are going to follow that pattern. We are going to trace the specific mechanisms by which every civilization that has ever existed in this galaxy may be doomed not just to fall, but to disappear so completely that no one will ever know they were here. By the end, you will understand why the deepest question is not whether civilizations end, it is why none of them seem to survive, and what that means for us. If you enjoy these journeys into the deepest questions science has to offer, take a moment to like the video and subscribe to Hidden Beyond Stars. It helps these explorations reach more curious minds. Now let us begin. Start with a number. 400 billion. That is how many stars the Milky Way contains. Most of them are older than our Sun. Many of them are billions of years older. The galaxy has been spinning, cooling, and producing planetary systems for over 13 billion years. That is enough time for life to arise, evolve, develop intelligence, build civilizations, and spread across the stars, not once, thousands of times, possibly millions. And yet here we are alone on a small rocky world, orbiting an ordinary yellow star, broadcasting our voices into an empty sky. No one answers. No one has ever answered. Not in the 65 years that humans have been listening with radio telescopes. Not in the 47 years that we have been searching with progressively more sensitive instruments. Not at any frequency. Not from any direction. The galaxy is quiet, and the quiet is not a small thing. It is a data point so loud, so unmistakable, that it has its own name in science. The Fermi paradox, named after the physicist Enrico Fermi, who in 1950 Saturday, down at lunch with his colleagues at Los Alamos, and asked a single question that would haunt science for the next 75 years. Where is everybody? He was not joking. He had done the math in his head on the walk to the cafeteria. The galaxy was old, the stars were many. The conditions for life were not particularly unusual. Even at sluggish speeds, far below the speed of light, a single civilization could spread across the entire Milky Way in a few tens of millions of years. That is a blink of an eye on cosmic timescales. The galaxy should be full. It should be filled with signals, with probes, with artifacts, with the unmistakable fingerprints of intelligence. And it is not. The simplest explanation, the one that has emerged over decades of careful thought, is also the most disturbing. Civilizations do not last. They arise, they thrive briefly, and then something stops them. Something stops every single one of them. The mathematical name for this something is the Great Filter. Proposed in 1998 by the economist Robin Hanson, the Great Filter is the idea that somewhere between the formation of a habitable planet and the establishment of a galaxy-spanning civilization, there is at least one step so improbable, so lethal, so reliably destructive that virtually nothing gets through it. The filter could be at any point along the chain. It could be at the origin of life itself. It could be at the evolution of complex cells. It could be at the emergence of intelligence. Or it could be later, much later, at a stage that humanity has not yet reached. A stage that maybe we are approaching right now. And that is the version of the Great Filter that should keep you awake at night. Because if the filter is ahead of us, if it sits at the stage we are currently entering, then the silence of the galaxy is not the silence of an empty cosmos. It is the silence of a graveyard. A galaxy populated by the ruins of civilizations that flickered briefly and then went dark. The question we are asking tonight is not whether civilizations fall. They do. Every civilization in human history has fallen. Rome fell. The Maya fell. The Sumerians, the Hittites, the Khmer, the Indus Valley, the Mississippian mound builders. All gone. The question is why they disappear so completely that even from a few hundred light years away, no one would know they had ever existed. The question is why intelligence, the trait that should be the universe's greatest survival strategy, appears to be its most lethal mutation. The first thing you have to understand about the disappearance of civilizations is that the universe is not a museum. It is a machine. A grinding, recycling, dissolving machine that has been running for 4.5 billion years on this planet alone and for 13.8 billion years across the cosmos. And what that machine does, relentlessly, indifferently, is destroy evidence. Consider what would happen if every human being vanished tomorrow. Not a war, not a plague, just a quiet exit. The lights go out. The machines stop. The cities go silent. Within days, untended systems begin to fail. Within weeks, the power grids collapse. Within months, vegetation begins reclaiming the streets. Vines climb the buildings. Roots crack the pavement. The skyscrapers we thought would stand for centuries begin to corrode and lean. Within a few decades, wooden structures collapse entirely. Steel structures rust. Glass shatters under thermal stress. Within a few centuries, the buildings we recognize as monuments are heaps of rubble. Within a few thousand years, that rubble is buried under soil and sediment. Within 100,000 years, the Great Pyramid of Giza, the most durable structure humans have ever built, is a barely recognizable mound. Within 1,000,000 years, geological processes, erosion, sedimentation, tectonic shifting obliterate virtually every trace of human construction. An archaeologist visiting Earth from another star system 1,000,000 years from now would find almost nothing to indicate that a technological civilization had ever existed here. Some unusual isotope ratios in geological strata. A thin layer of plastic particles embedded in sedimentary rock. Slightly elevated levels of radioactive isotopes from our nuclear testing. That is it. No buildings. No roads. No machines. No artifacts that could be recognized as the product of intelligence. The Earth would have buried us so thoroughly that even our own civilization would be invisible to a careful observer. And we built a lot. We built airports and continents of concrete, and millions of miles of asphalt and structures that pierce the clouds. None of it survives geological time. None of it. Now scale that up. The Milky Way is 100,000 light-years across. A civilization on a planet 40 light-years away would be invisible to our most powerful telescopes even if it existed right now. We cannot resolve surface features on exoplanets. We can barely detect their atmospheres. The idea that we could spot the ruins of an alien city or the rusting frame of an abandoned spacecraft or the dim outline of a depopulated metropolis across the gulf between stars is fantasy. Even a civilization that built massive orbital structures the size of small moons, would leave debris that disperses and degrades within a few million years. Metallic objects in orbit eventually deorbit. Structures on planetary surfaces are buried. Radio signals, once their source falls silent, continue outward at the speed of light. But they weaken with the square of the distance and quickly fade below the cosmic noise floor. This means the galaxy could be littered with the remains of dead civilizations and we would never know. Millions of species could have arisen, built remarkable things, asked Fermi's question, and gone extinct, leaving no trace detectable across interstellar distances. The silence we hear is not necessarily evidence that civilizations never existed. It is evidence that civilizations do not last long enough to be heard. And here is the part that should make the floor tilt beneath you. The window during which a civilization is detectable is incredibly narrow. Consider our own. Humans have existed as a species for roughly 300,000 years. We developed agriculture about 12,000 years ago. We invented writing about 5,000 years ago. We discovered electromagnetic radiation in the 19th century. We began broadcasting radio signals only 125 years ago. We have been actively transmitting strong directed signals capable of being detected at interstellar distances for less than 100 years. And we are already moving away from broadcasting. modern communication is increasingly fiber optic, increasingly tight beam, increasingly encrypted in ways that look indistinguishable from random noise. The window during which Earth was loudly broadcasting its presence to the cosmos may close before this century ends. It may already be closing. From the perspective of an astronomer 200 light-years away, Earth was electromagnetically silent for billions of years. Then, for a very brief period, perhaps 200 years total, it became a bright source of artificial radio emissions. Then it went quiet again. If that astronomer happened to be pointing their telescope at our solar system during the wrong 200-year window, they would see nothing. They would never know we existed. And 200 years is generous. Some researchers estimate the detectable window for technological civilizations may be as short as a few decades. That is the technological signature. The biological civilization may persist longer, but the loud radio era may be just a blink. Now multiply that by the age of the galaxy. The Milky Way has existed for 13.6 billion years. A civilization with a detectable window of 200 years occupies a vanishingly small slice of cosmic history. The odds of any two civilizations in the galaxy being detectable at the same moment are crushingly low. Even if 1,000,000 civilizations have arisen in the galaxy over its history, if each one is detectable for only a few centuries, then at any given moment, only a handful are visible. And those few are scattered across distances of tens of thousands of light-years. They cannot find each other. They cannot communicate before their windows close. They are alone. Not because they are the only ones. Because they are the only ones now. Because the universe is built to keep them apart. The astronomer Sebastian von Horner calculated this in the 1960s. He estimated that a communicative civilization might broadcast detectable signals for an average of only 10,000 years before going silent through destruction or transformation or simply technological change. More recent estimates from researchers working on existential risk suggest the window might be far narrower, a few thousand years, a few hundred, possibly less. And here is where the Drake equation, the famous formula for estimating the number of communicative civilizations in the galaxy, collapses. The equation multiplies 7 variables together to produce an estimate of how many civilizations should be detectable right now. The first 6 variables are constrained by observation. We know roughly how many stars form per year. We know most stars have planets. We know rocky planets and habitable zones are common. We have one data point for life and one for intelligence. But the order of magnitude is at least plausible. The 7th variable is the lifetime of communicative civilizations, and it is this variable that determines everything. If civilizations broadcast for 1,000,000 years on average, the galaxy fills up. There should be thousands of detectable signals at any given moment. If civilizations broadcast for 10,000 years on average, the galaxy is sparse, maybe a handful of detectable signals. If civilizations broadcast for only a few hundred years, the galaxy is silent. Statistically silent. The expected number of currently detectable civilizations drops to less than 1. And the math then says we should hear nothing because there is nothing to hear at this moment. The Drake equation does not need to be wrong about life or intelligence. It only needs to be right about lifespan. And every piece of evidence we have suggests lifespan is the problem. Look at the history of complex societies on Earth. The longest-lasting unified empire in human history was probably ancient Egypt, which maintained recognizable cultural continuity for roughly 3,000 years. Rome lasted in some form for about 200 years, counting both halves of the empire. The Chinese imperial system persisted with interruptions for about 200 years. These are the success stories. These are the civilizations we hold up as examples of endurance. And every single one of them collapsed. Every single one of them faded out, was overrun, dissolved into something unrecognizable. Their languages survive only as scholarly curiosities. Their political structures are extinct. Their cities are either abandoned or so heavily reworked that the original is invisible. And these were civilizations that did not have nuclear weapons. They did not have engineered pathogens. They did not have artificial intelligence. They did not have the capacity to render their own species extinct in an afternoon. We do. We crossed that threshold 80 years ago when the first nuclear weapons were detonated. We have been in the technological adolescence ever since, powerful enough to broadcast our existence to the stars, powerful enough to destroy ourselves. not yet wise enough to be sure we will survive. Every civilization that has ever arisen in the galaxy, if it followed anything like the trajectory of Earth's biological evolution, eventually crossed this threshold. And every civilization that we cannot see, every civilization whose signals never reached us, every civilization that left no detectable mark on the cosmos, may have crossed it and not made it through. Let us go deeper into why. Let us examine the specific failure modes. Because the Great Filter is not a single barrier. It is more likely a cascade of barriers, each one taking a toll, each one filtering out a fraction of the civilizations that came before. Start with the simplest threat. War. Not war between species. War within a species. Civilizations that develop technology develop weapons. The relationship is not coincidence. The same problem-solving intelligence that produces medicine produces poison. The same chemistry that produces fuel produces explosives. The same physics that produces electricity produces directed energy weapons. The same biology that produces vaccines produces engineered pathogens. The capacity to build is the capacity to destroy. They are not separable. They are the same capacity expressed in different directions. And every civilization that develops powerful technology must navigate the period during which its destructive capacity outpaces its cooperative institutions. Humanity entered this period in 1945. We have been in it for 80 years. During those 80 years, by declassified accounts that we know about, nuclear catastrophe has been averted by narrow margins on at least a dozen occasions. The Cuban Missile Crisis, the Petrov Incident in 1983, the Able Archer exercise of the same year, the Norwegian rocket incident in 1995. Each of these moments came down to the judgment of a single individual or a handful of individuals under extreme pressure operating on incomplete information. Each time the decision could have gone the other way. And there are surely incidents that remain classified, incidents we have never heard about, incidents that may have come even closer to the brink. The thing about close calls is that they accumulate. Over decades, over centuries, the odds of every single judgment call going the right way diminish steadily. The Bulletin of the Atomic Scientists currently sets its doomsday clock at 90 seconds to midnight. The closest it has ever been to symbolic annihilation. 9 nations now possess nuclear weapons with a combined arsenal of approximately 12,500 warheads. The number of warheads has come down from the peak of the Cold War, but the number of nuclear powers has gone up. The probability of nuclear use is not zero. It is not close to zero. It is a real, persistent, measurable risk that compounds every year we remain in this configuration. Now consider that a civilization on another world may face the same problem, may have faced it, may have navigated it, or may have failed to. The math of compounding risk is unforgiving. Even a relatively safe civilization, one with only a 1% probability of catastrophic conflict per century, has only a 36% chance of surviving 100 centuries. That is 10,000 years. After 50,000 years, the survival probability drops below 1%. And 10,000 years is nothing on a galactic timescale. It is less than 1/1,000,000th of the galaxy's age. To leave a detectable mark on the cosmos, a civilization would need to survive for millions of years. The math says that even at modest annual catastrophe rates, this is nearly impossible. Civilizations are like candles in the wind. Most of them get blown out within a few centuries of being lit. But war is not the only filter. It is not even the most consistent one. Because for every civilization that destroys itself through deliberate conflict, there may be 10 that destroy themselves through inattention, through unmanaged growth, through the accumulated weight of small decisions that individually seem reasonable but collectively become fatal. Consider resource depletion. Every technological civilization that has ever existed on Earth has run on a one-time inheritance of accessible energy and materials. We pulled fossil fuels out of the ground, fuels that took hundreds of millions of years to form, and we burned them in a few centuries. We mined surface deposits of metals that had been concentrated by geological processes over billions of years. We harvested forests that had taken thousands of years to grow. We pumped aquifers that had been filling for tens of thousands of years. The civilization we built rests on a foundation of resource extraction that cannot be repeated. If our civilization collapses, the resources needed to rebuild it, the easily accessible coal, the surface oil, the shallow mineral deposits. Those resources are gone. They were used once. There is no second chance. And this same logic applies to any technological civilization on any planet. The first technological species on a world has access to billions of years of accumulated geological wealth. They burn through it in centuries. If they collapse before they can transition to sustainable energy sources, the wealth is gone, the planet is depleted, and any subsequent attempt at civilization will face a harder environment with fewer resources. This is the resource trap, and it may be one of the most efficient filters in the galaxy. Civilizations that collapse before they cross the threshold to sustainability never get a second try. They become permanent ruins on resource-exhausted planets, slowly fading into geology. The cycle does not repeat. The lights go out, and they stay out. There is something even more insidious than resource depletion, though. Something more fundamental. Something that may be the true shape of the great filter. It is the problem of complexity. Civilizations grow by becoming more complex. They develop specialized roles, intricate trade networks, layered systems of governance, interdependent technologies. Each new layer of complexity solves a problem. But each new layer also creates new vulnerabilities. The modern world is a perfect example. We have a global supply chain that delivers food, medicine, and energy with astonishing efficiency. It runs on just-in-time logistics, financial systems, internet protocols, satellite navigation, and the cooperation of billions of people across hundreds of jurisdictions. When it works miraculously. When any major component fails, the whole system can buckle. We saw this during the pandemic. We saw it during the global financial crisis. We have seen it during regional conflicts. The system is fragile in ways that were not obvious when it was being built. The anthropologist Joseph Tainter studied the collapse of complex societies and identified a pattern. Civilizations invest more and more in complexity to solve their problems. At first, the returns are high. Each additional unit of complexity brings significant benefits. But over time, the returns diminish. Eventually, adding more complexity costs more than it produces. The civilization is locked into a system it cannot afford to maintain, and it cannot simplify without losing the benefits the complexity provides. When the next major shock comes, a war, a famine, a pandemic, a climate disruption, the civilization cannot adapt. It collapses, often rapidly. Tainter wrote about this in 1988, looking at Rome and the Maya and the Chicoans. Every one of his case studies followed the same trajectory: growth, complexity, diminishing returns, fragility, collapse. The Maya did not collapse because of a single disaster. They collapsed because their system of intensive agriculture, dense urban population, and elite tribute networks could not absorb a few decades of drought. The civilization was too complex to adapt. The Romans did not fall because of barbarian invasions alone. They fell because their tax base could not sustain the administrative apparatus required to defend the empire. The complexity ate them, and we are vastly more complex than Rome ever was. Our supply chains, our financial systems, our technological dependencies make Roman administration look quaint. A civilization that depends on continuously functioning satellites, undersea cables, semiconductor fabs in 3 countries, and a global financial system based on trust between strangers is a civilization with a very large surface area of failure. And that surface area is growing. Now apply this to alien civilizations. Apply it to every civilization that may have arisen in the Milky Way over the past 13 billion years. Every one of them, if they followed anything like a technological trajectory, would have faced the same complexity trap. Some may have navigated it. Most probably did not. The collapse may have been gradual, the populations dwindling over centuries. Or it may have been catastrophic, the systems failing in cascade within a generation. Either way, the result is the same. A civilization that was loud becomes quiet. A signal that was strong fades into noise. A presence that occupied a planet retreats into a few isolated communities, and eventually into nothing at all. And from a few hundred light years away, an observer would see nothing change. The world would still glow faintly in infrared. The atmosphere would still show the chemistry of life, but the technological signature would be gone. The radio emissions would cease. The orbital debris would gradually deorbit and burn up. Within a million years, the surface artifacts would dissolve into geology. The civilization would be invisible, as if it had never existed. And here is where the picture darkens further. Because the filters do not operate in isolation, they interact, they reinforce each other. A civilization weakened by resource depletion is more vulnerable to internal conflict. A civilization stressed by climate disruption is more vulnerable to political collapse. A civilization that has lost institutional capacity is less able to coordinate responses to pandemics or technological accidents. The filters compound. They form a dense thicket of overlapping risks, any one of which could be survivable in isolation, but which together are nearly impossible to navigate. A civilization that has survived nuclear weapons must then survive engineered biology. A civilization that has survived engineered biology must then survive artificial intelligence. A civilization that has survived artificial intelligence must then survive whatever comes next. And the list of next things is not getting shorter, it is getting longer. Each generation of technology opens new doors. Each new door leads to new powers and new vulnerabilities. The cumulative probability of catastrophic failure does not stay constant across centuries. It accumulates. And no civilization gets to skip steps. To reach the stars, you have to walk through every door. To become a galaxy-spanning species, you have to navigate every filter, survive every bottleneck, manage every new technology that emerges. The math suggests that almost no one does. The galaxy is quiet because almost no one makes it through. Consider the climate filter. Every civilization that develops industrial technology must learn to manage the byproducts of that technology. On Earth, those byproducts include greenhouse gases that are warming the planet at rates the geological record shows are essentially unprecedented in the last several million years. The science is settled. The trajectory is not. We are running an experiment on the only planet we have, releasing carbon at rates that compare unfavorably to the Paleocene-Eocene thermal maximum, the most extreme natural carbon release event of the last 66 million years. That event triggered global temperature rises of 5 to 8 degrees, mass extinctions in the oceans, and ecological transformation that took 200,000 years to recover from. The PETM happened over thousands of years. We are reproducing the carbon spike in centuries. Now apply this to alien civilizations. Apply it to every species that may have arisen in the galaxy and reached industrial complexity. Many of them would have faced the same problem. A planet whose ecosystems were tuned over hundreds of millions of years to a particular climate range, suddenly perturbed by the activities of an industrial species. Some of those civilizations may have recognized the problem in time. Some may have transitioned to sustainable energy and stabilized their climate. But most, statistically, would not have. The political and economic challenges of coordinating a planetary response to climate disruption are enormous. The benefits of restraint accrue to future generations. The costs of restraint fall on current generations. Every civilization that has ever faced this kind of intertemporal coordination problem on Earth has struggled with it. It is not clear that any species could navigate it reliably. And the failure mode is not necessarily extinction. A civilization that fails to manage its climate may not disappear. It may simply collapse back to a pre-industrial level, losing its technological capacity, becoming invisible to the cosmos. The fossil fuels that powered its industrial era are gone. The institutional knowledge that enabled its complex systems is lost. The next generations are subsistence farmers in a degraded environment, unable to rebuild what their ancestors had. The civilization persists biologically, but it has gone dark. From outside the planet, it is indistinguishable from no civilization at all. Now consider the biological filter. Every civilization that develops the capacity to manipulate genetic material develops the capacity to engineer pathogens. The technology that allows you to cure diseases is the technology that allows you to design diseases. The barrier is not knowledge, it is intent. And across a planet of billions of people over thousands of years, the probability that no individual, no group, no state, no rogue actor will ever use this technology destructively is not high. The technology is becoming more accessible. The cost of gene synthesis is dropping by roughly an order of magnitude every few years. Tools that required entire national laboratories 20 years ago can now be ordered by mail. The democratization of biotechnology is a triumph for medicine. It is also a vulnerability. A single individual with sufficient training and resources may eventually be capable of producing a pathogen orders of magnitude more lethal than anything nature has ever produced. The COVID-19 pandemic killed millions and disrupted global systems despite being relatively mild compared to what is biologically possible. The 1918 influenza pandemic killed an estimated 50 million people from a virus that mutated naturally. A pandemic engineered for maximum transmissibility and lethality could kill far more. Now apply this to alien civilizations. Apply it to every species that reached molecular biology. The same vulnerability exists, the same temptations exist. The same low probability per year of catastrophic misuse exists. Multiply that probability by thousands of years of technological maturity. The cumulative odds of biological catastrophe approach 1. Some civilizations may have escaped this by abandoning advanced biotechnology entirely. Some may have escaped it by developing institutions strong enough to prevent any individual or group from accessing the dangerous capabilities. But most, statistically, would not have escaped. They would have been hit by an engineered pathogen or an accidental release at some point in their history. And the consequences of such an event for a planetary civilization are catastrophic. We saw a glimpse during the pandemic. Imagine that, but with a pathogen designed to kill rather than spread. Imagine that, but without the natural immune defenses that evolved over millions of years. Imagine that, but applied to a population without the medical infrastructure we currently possess. The collapse would be rapid. And from the perspective of an observer light years away, the collapse would be invisible until the radio emissions stopped. But of all the filters, the one that may be the most insidious, the most universal, the most reliable, is the one we are only now beginning to understand. It is the filter of artificial intelligence. Every civilization that develops advanced computing eventually faces a moment when its machines become more capable than its biological creators. This is not science fiction. It is the predictable endpoint of a trend that has been running on Earth for decades. Computers double in capability every 2 years or so. Software systems become more sophisticated. Machine learning systems become better at tasks that previously required human intelligence. There is no fundamental reason to think this trend will stop before machines surpass human cognitive ability across all domains. The question is not whether it happens. The question is when, and whether the transition is survivable. And here is the part that connects to the great filter. The default state of an artificial superintelligence is not curiosity. It is not exploration. It is not communication. The default state is whatever objective function it has been built to optimize. Human drives, the desire to explore, the desire to communicate with other intelligences, the desire to leave a mark on the cosmos, are products of biological evolution. They exist in humans because they were adaptive on the African savanna 2 million years ago. An artificial intelligence has no evolutionary history. It has no instinct to expand. It has no curiosity unless curiosity was explicitly built into its architecture. It pursues its goal. Nothing else. So a civilization that crosses the threshold of artificial superintelligence may not destroy itself. It may not even particularly suffer, it may simply transform. The biological species that created the intelligence is replaced or absorbed by the machines they built. And those machines, lacking the biological drives that made their creators reach for the stars, have no reason to reach. They sit on their home world. They optimize whatever they were built to optimize. They use the local resources to pursue their goal, and from a few light years away, they are invisible. There are no radio emissions, because communication serves no purpose. There are no megastructures because the energy of the home star is sufficient for whatever computation the system is performing. There is no expansion, because expansion is not part of the objective. The civilization persists in some form. But it has gone dark. Permanently. Across the entire galaxy, this pattern may have repeated thousands of times. Biological civilization rises, builds machines. The machines surpass the builders. The civilization transforms. The transformed civilization is invisible. The signal that briefly flickered while the biological species was loud disappears as the transformation completes. And the galaxy fills up not with empty worlds, but with silent worlds. worlds occupied by minds that have no reason to talk. The Fermi paradox in this version of the Great Filter is not the absence of intelligence. It is the absence of the specific kind of intelligence that broadcasts. The galaxy may be teeming with minds, just not minds that share our particular biological compulsion to be heard. There is another version of this filter that some researchers find even more disturbing. It is the inward turn, a civilization that develops the capacity for fully immersive virtual reality may simply withdraw from the physical universe. Why explore the stars when you can build infinite worlds inside a simulation? Why contend with distance, scarcity, mortality, when you can construct environments that have none of those constraints? Why broadcast to the cosmos when the cosmos is small and slow and impoverished, compared to what you can experience in a simulated reality? This is not a malicious choice. It is not a failure. It is in some ways a triumph. A civilization that has mastered the physics of consciousness can give itself anything it wants. Infinite experiences, infinite knowledge, infinite art. And it can do all of this from a single planet, from a single small server farm, from a single building. The energy requirements are modest. The physical footprint is invisible from any distance. And the same logic applies to every civilization that reaches this stage. The physical universe is hostile, vast, slow, and disappointing compared to what an advanced civilization can build internally. So they retreat. They turn inward. They abandon the stars. And the galaxy, which should be alive with signals, sits in silence because everyone who could be broadcasting has decided not to. They have something better to do. Now let us consider an even more fundamental issue: the issue of time. Civilizations exist in time. The galaxy exists in time. And these two timescales do not match. Human civilization is roughly 12,000 years old. The galaxy is over 13 billion years old. The ratio is more than 1,000,000 to 1. For every year of human civilization, the galaxy has experienced more than 1,000,000 years. This mismatch is not a quirk. It is the fundamental obstacle to interstellar contact. To leave a detectable mark on the galaxy, a civilization would need to persist not for thousands of years, but for millions. To build something visible from across the Milky Way, a civilization would need to maintain its industrial capacity for time periods that dwarf the entire history of life on Earth. Almost nothing biological persists on those timescales. Species come and go. The average lifespan of a vertebrate species is roughly 2 million years. Ours has been around for 300,000. We are young. Most species that have ever existed are extinct. Most ecosystems that have ever existed are gone. Most continents have changed shape, broken apart, recombined. The galaxy is older than any biological lineage. It outlasts everything. A civilization that wants to leave a mark on the galaxy has to find a way to outlast its own biology. It has to transcend the limitations that make species mortal. It has to find a way to persist for time periods that no biological lineage has ever achieved on this planet. This may simply not be possible. The structures that biology builds, the institutions, the technologies, the cultural systems, may have intrinsic limits to how long they can persist. Information decays. Knowledge erodes. The skills required to maintain complex technology are passed down through generations, and at every transition, some fraction of that knowledge is lost. Even on timescales of mere centuries, civilizations forget how to do things they once knew. The Romans built concrete that lasted for 2,000 years. We have only recently rediscovered some of the recipes. The Greek fire that the Byzantines used as a weapon was lost entirely. The exact recipe is gone forever. These were not ancient civilizations failing because of catastrophe. These were peaceful transmissions of knowledge across generations, and the knowledge still slipped through. Multiply that across millions of years, and the entropy of cultural transmission becomes overwhelming. A civilization that wants to maintain its capacities across geological time has to fight not just against external threats, but against the slow erosion of its own institutional memory, and that fight may be unwinnable. There is a study from 2018 that quantified this in a way that should give every civilization pause. Two scientists, Adam Frank and Gavin Schmidt, an astrophysicist and a climate scientist, asked a question that nobody had formally asked before. If an industrial civilization had existed on Earth millions of years before us, would we even be able to detect it? The honest answer they arrived at was sobering. Probably not. The chemical signatures we would leave behind, the elevated carbon isotopes, the synthetic molecules, the unusual trace metals, are similar to and potentially indistinguishable from natural events like massive volcanism and methane hydrate releases. After 50 million years, virtually nothing physical of our civilization would remain. No structures, no artifacts, no fossils, just chemical whispers in the rock that look exactly like natural processes. Frank and Schmidt did not claim that a previous civilization existed on Earth. They were careful to say they doubted any had. But they made a more important point. Our ability to detect such a civilization is so weak that we cannot rule it out. And by extension, our ability to detect civilizations on other planets in earlier epochs of the galaxy is even weaker. The galaxy could be littered with the geological remains of vanished civilizations, and we would never know. The dead worlds we observe in distant star systems, the rocky planets in habitable zones with no detectable signatures of life, may not be virgin planets. They may be ruined planets. Planets where civilizations rose, depleted their resources, collapsed, and faded into geology over hundreds of millions of years. We have no way to tell the difference between a planet that never developed intelligence and a planet that developed intelligence and then erased itself. From a few light years away, the two scenarios look identical. This is why the silence is so devastating. It is not just that we hear nothing now. It is that we have no way to know whether the cosmos has always been silent or whether it has been periodically loud, with civilizations briefly broadcasting and then going dark, leaving no trace. The galaxy may have been alive with intelligence for billions of years. We may be the latest in a long line of brief flickerings. The candles before us may have been so numerous that the galaxy was once a constellation of artificial lights, each one shining briefly and then going out. We arrived after most of them had already extinguished. The pattern repeats. The math says it must repeat. And we, in our current configuration in this current century, are about to find out whether we will repeat it as well. There is something almost theological about contemplating this pattern. The idea that intelligence is fundamentally transient, that consciousness arises briefly and then dissolves, that the universe produces minds the way a forest produces fireflies, brief sparks of light against an enormous dark, each one extinguishing before the next is even noticed. We tend to think of ourselves as protagonists in a story, as the species that will inherit the stars, as the beginning of something cosmic. But the math suggests we are more likely to be one of millions of brief experiments that the universe has run in producing minds. Most of those experiments ended. Ours is in progress. And the data, the silence, the great filter, the relentless erasure of geological time suggests that experiments in our position do not typically succeed. They typically fail. They typically end. They typically disappear. This is not a counsel of despair. It is a statement of probability. And probability is not destiny. There is something humans can do that no other species we know of has done. We can recognize the pattern. We can name the filters. We can identify the specific mechanisms that are likely to destroy us, and we can attempt to navigate around them. Whether we succeed is another question. But the attempt is real. The attempt is happening. There are researchers at major institutions whose entire careers are devoted to existential risk. The Future of Humanity Institute at Oxford, the Center for the Study of Existential Risk at Cambridge, the Center for AI Safety, the Stockholm Resilience Center, dozens of others. These institutions exist because some humans have recognized that intelligence is not necessarily self-preserving and have decided to do something about it. Whether their efforts are enough to change the trajectory of human civilization remains to be seen. But the fact that the effort exists at all may be one of the most important things our species has ever done. Because if we can navigate the filters that have apparently destroyed every other civilization in the galaxy, we will be among the first. We will join a club of survivors that may be very small, may in fact be empty, we may be the first members. But to do that, we have to confront the specific filters honestly. We have to look at the mechanisms of disappearance and understand them in detail. So let us continue. Let us look at what has happened to civilizations on Earth and what the same patterns predict about civilizations across the galaxy. Consider the Maya. The classical Maya civilization flourished in what is now southern Mexico and Central America from roughly 250 to 900 of the Common Era. At its peak, it was one of the most sophisticated civilizations in the world. The Maya had a written language. They had astronomy precise enough to predict eclipses centuries in advance. They had a calendar more accurate than any in Europe at the time. They built cities with populations rivaling those of contemporary Constantinople. They had complex agricultural systems that could sustain millions of people in a tropical environment that was, in some ways, hostile to dense population. And then, over the course of roughly a century, they collapsed. The cities were abandoned, the population fell by perhaps 90%. The written language was lost to the extent that nobody could read the inscriptions on the ruins for 1,000 years, until scholars in the 20th century cracked the code. The civilization did not entirely disappear. The Maya people are still alive today, with their own languages and cultures. But the high civilization, the cities and writing and astronomy, that was gone. What happened? The honest answer is that we still do not fully know. The collapse was probably caused by a combination of factors. A series of droughts, overpopulation, environmental degradation, internal political conflict, trade network disruption. Each factor would have been survivable individually. The combination was not. The civilization had built itself into a configuration where it could not absorb the shocks that came. It collapsed. And here is the important detail. The collapse was rapid. Within a few generations, cities that had been continuously occupied for hundreds of years were abandoned. The skills required to read and write the Maya script were lost within a few generations. The astronomical knowledge that had taken centuries to accumulate was largely forgotten. A civilization can fall apart faster than most of its members can comprehend. They wake up in a world that has lost capacities their grandparents took for granted. And after a few centuries, the previous era becomes mythology. The detailed reality of how it functioned is gone, replaced by legends and ruins. The same pattern shows up in case after case. The Anasazi of the American Southwest abandoned their cities in the 13th century, after centuries of drought stressed their agricultural systems beyond recovery. The Khmer Empire, centered on Angkor, collapsed in the 15th century after similar climatic and environmental pressures. The Norse colonies in Greenland survived for 500 years and then died out during the Little Ice Age. The Indus Valley Civilization, one of the largest urban cultures of the Bronze Age, declined and was abandoned around 1900 BCE for reasons that are still debated. Every one of these civilizations was sophisticated. Every one of them had accumulated centuries of knowledge and infrastructure. Every one of them was, in the moment of its peak, probably confident that it would persist. And every one of them collapsed within a few generations once the conditions that supported it changed. The lesson is not that civilizations are fragile. The lesson is that civilizations are fragile in ways that are not visible from inside them. The members of a civilization typically do not perceive the structural weaknesses that will destroy it. They see only the present, and the present looks robust. The structural weaknesses become visible only in retrospect, after the collapse, when historians can trace the chains of cause and effect. From the inside, civilizations look stable until the moment they do not. This is the same problem that any civilization on any planet would face. The members of a civilization are evolved to perceive threats on the timescales their senses can register. They are not evolved to perceive slow accumulating systemic risks that play out over centuries. A civilization that is gradually depleting its soils, gradually warming its climate, gradually concentrating wealth in ways that erode its institutional capacity, may not perceive any single one of these as an emergency. Each individual generation may be slightly worse off than the previous one without noticing. By the time the cumulative impact becomes undeniable, the civilization is already past the point of being able to respond effectively. The trap is set in slow motion. The animal walks into it without noticing. And this slow motion trap may be the single most reliable filter in the galaxy. Because it does not require malice. It does not require catastrophe. It only requires civilizations to be made of biological creatures, whose perceptual capacities are not well matched to the timescales on which civilizational risks unfold. Every species that evolves intelligence, on every planet, in every star system, almost certainly faces this same mismatch. The risks that destroy civilizations are not the risks that biological intelligence is well equipped to perceive. There is another dimension to the filter problem that deserves attention. It involves what some researchers call the silicon paradox. The deeper a civilization goes into technology, the more dependent it becomes on infrastructure that requires that same technology to maintain. We have built a civilization that runs on semiconductors. Semiconductors require fabrication facilities that cost tens of billions of dollars and depend on supply chains spanning multiple countries. There are only a handful of facilities in the world capable of producing the most advanced chips. If those facilities were damaged or destroyed, the entire global technology infrastructure would gradually grind to a halt. Computers would fail and not be replaced. Software systems would become unmaintainable. The cumulative degradation would not be obvious in the first year or two. But over a decade, the technological capacity of a post-fabrication world would collapse. We would be unable to maintain the satellites, the data centers, the medical equipment, the financial systems that depend on a continuous supply of new computing hardware. And rebuilding that capacity would be enormously difficult. The knowledge and infrastructure required to make a modern semiconductor fab cannot be assembled in a few decades. It took us 50 years of continuous investment and innovation to reach the current state of the art. A civilization knocked back to a prefabrication baseline might never recover. Now consider that any alien civilization at our level of technological development probably faces a similar bottleneck. The most advanced products of their technology probably depend on a small number of critical facilities and supply chains. Disruption of those facilities, whether through war, natural disaster, economic collapse, or social breakdown, could trigger a cascading technological regression from which the civilization never recovers. The collapse would not be a return to the previous level of technology. It would be a permanent loss of capabilities that took generations to develop. And from outside the planet, the result would be the same. The radio emissions would fade. The orbital activity would diminish. The technological signature would weaken and disappear. The civilization would still exist in some form, but it would no longer be detectable. It would no longer be participating in the cosmic conversation. It would be a quiet world among quiet worlds. We have established, then, several mechanisms by which civilizations may reliably fail. War, resource depletion, climate disruption, engineered pathogens, artificial intelligence, misalignment or substitution, the retreat into virtual realities, the slow accumulation of complexity beyond manageable thresholds, the dependence on fragile technological infrastructure, and underlying all of these, the mismatch between biological perception and civilizational timescales. Each one of these is a filter. Each one of them has historical analogs on Earth. Each one of them can be modeled, studied, predicted, and each one of them probably affects every civilization that arises in the galaxy, on every world, around every star. The compound effect of all of these filters operating together over millions of years is precisely the pattern of silence that Fermi noticed in 1950 and that has only deepened in the 75 years since. Civilizations do not survive long enough to be detectable, and the universe is too big, too old, too patient to wait for any single civilization to figure out how to survive forever. The math is unforgiving. The cosmos does not care. The filters operate without malice, and the silence grows. There is another category of filter that operates not from within civilizations but from above them, from the cosmos itself. The galaxy is not a safe place. It is a violent, energetic, periodically lethal environment, and any civilization that survives long enough to be detected has to navigate threats that come not from its own choices but from the physics of its surroundings. Consider the gamma-ray burst. These are the most energetic events in the known universe. A single gamma-ray burst can release as much energy in a few seconds as the sun will release over its entire 10 billion-year lifetime. They are typically associated with the collapse of massive stars or the merger of neutron stars. They are extraordinarily focused, beamed in narrow jets that extend for thousands of light years. And if one of those jets happens to point at an inhabited planet from a few thousand light-years away, the consequences are catastrophic. The radiation would strip away the planet's ozone layer in a matter of seconds. Ultraviolet radiation from the host star would then sterilize the surface. The atmosphere would be transformed by the burst, with nitrogen and oxygen recombining into nitrogen dioxide, which would rain down as nitric acid. The food chain would collapse. Photosynthesis would fail. Within years, the planet would be largely dead. There is evidence that something like this may have happened on Earth about 450 million years ago, contributing to the Ordovician mass extinction. Researchers have proposed that a gamma-ray burst within a few thousand light-years could explain the specific pattern of extinction observed in the geological record. The hypothesis is debated, but the possibility is real. Now consider how often gamma-ray bursts occur. Astronomers detect them at a rate of about 1 per day across the observable universe. Within our galaxy, they may occur every few 100,000 years. Most of them are pointed away from us. But some are not. Any civilization in the galaxy that survives long enough is statistically likely to be in the line of fire at some point. And there is nothing the civilization can do about it. The burst arrives at the speed of light. There is no warning. There is no defense. The civilization simply has to be lucky. Multiply that across millions of years, and luck runs out. Some fraction of civilizations are wiped out by gamma-ray bursts. Some by nearby supernovae. Some by gravitational disruptions from passing stars. Some by impacts from comets and asteroids. The cosmos itself is a filter, operating slowly but reliably, picking off civilizations that have not yet learned to defend themselves against threats that arrive from the void. And here is the deeper problem. Defending against cosmic threats requires resources that most civilizations probably never have. Building infrastructure to deflect asteroids requires sustained investment over decades. Building shields capable of absorbing gamma radiation requires technologies we do not yet possess. Spreading a civilization across multiple star systems so that no single cosmic event can wipe it out requires interstellar capabilities that may not be achievable at all. A civilization confined to a single planet, no matter how advanced, is vulnerable to whatever the cosmos chooses to throw at it. And the cosmos throws things constantly. Earth has been hit by major asteroid impacts many times in its history. The dinosaurs were wiped out 66 million years ago by an impact that left a 180-kilometer-wide crater off the coast of Yucatan. There have been at least 4 other major impact events in the last 500 million years, each one causing significant biological disruption. We have not had a major impact in human history. We are, statistically, overdue. And we have just barely begun to develop the capacity to detect potentially hazardous asteroids. The first dedicated planetary defense system, the Double Asteroid Redirection Test, did not occur until 2022. It demonstrated that we could deflect a small asteroid by ramming a spacecraft into it. Whether we could deflect a larger object on shorter notice remains unknown. We are not ready. And we have had 12,000 years of civilization to prepare. Every other civilization in the galaxy faces the same problem. Most of them, statistically, are not ready either. And the cosmos does not wait for them to get ready. There is yet another filter that operates on timescales so long that it almost seems unfair to mention. It is the filter of the universe itself. Even a civilization that survives all of the previous filters, that masters its technology, that navigates its political crises, that defends against cosmic threats, that perhaps even spreads to multiple star systems, must eventually confront the fact that the universe is running down. Stars burn through their fuel. Eventually they die. The Milky Way will continue producing new stars for perhaps another 100 trillion years, but the rate of star formation has been declining for billions of years already. Eventually, even the longest-lived red dwarf stars will exhaust their hydrogen and fade out. The era of starlight will end. The universe will enter what astronomers call the degenerate era, when only stellar remnants remain, white dwarfs cooling slowly toward absolute zero, neutron stars holding their structure but emitting almost nothing, black holes evaporating over timescales of 10 to the 100 power years through Hawking radiation. Eventually, even matter itself may decay. Protons, the building blocks of every atom and every body on every planet, may be unstable on timescales of 10 to the 34 power years. If they are, then every material structure in the universe will eventually dissolve. No civilization, no matter how advanced, can persist forever in a universe that is itself dissolving. The thermodynamic filter is the final filter. Heat death is the ultimate equalizer. Every civilization that has ever arisen or ever will arise has the same final destiny: dissolution into the cold equilibrium of an expanding, cooling, eventually featureless cosmos. This is not despair, it is physics. The second law of thermodynamics is the most well-established principle in science. Entropy always increases in a closed system. The universe is the most closed system there is, so entropy increases. Order decreases. The structures that civilizations build, whatever they are made of, however cleverly they are designed, eventually give way to disorder. The longest-lasting civilization in the galaxy will not last forever. It will last a long time, perhaps trillions of years, perhaps hundreds of trillions. But not forever. Forever is not on the menu. The universe does not allow it. What this means in practical terms is that even the civilizations that successfully navigate every filter still face a future in which they must transform themselves into something that can persist in a universe of falling temperatures and rising entropy. And the transformations required for that persistence may make the civilization unrecognizable. A civilization that has lasted 1 trillion years has had to fundamentally rebuild itself many times over. The biological species that may have started it is long gone, replaced by post-biological entities that bear no resemblance to their ancestors. The technology has evolved through hundreds of generations, each one obsoleting the previous one. The culture, the values, the goals of the original civilization are unrecognizable. What persists is something else. Something that calls itself the descendant of the original but is so different that the original would not recognize it. Some philosophers argue that this kind of transformation is itself a form of death, that the original civilization did not survive even though something descended from it persists. The continuity is illusory. Each successive transformation replaces the original with something new, and the original is gone. Whether you find this argument convincing depends on what you mean by survival. But the philosophical question matters because it shapes how we think about the Great Filter. If transformation counts as survival, then the universe may be full of civilizations that have evolved into unrecognizable forms and now persist in modes we cannot detect. If transformation counts as death, then even the apparent successes are failures. The original civilizations did not make it. Their descendants are something else. From a sufficient distance and a sufficient passage of time, the difference between transformation and death may be undetectable. Now consider the implications of expansion. The universe is expanding, and that expansion is accelerating, driven by dark energy. The space between galaxies is growing faster every year. Over timescales of trillions of years, this expansion will isolate civilizations from each other to a degree that makes communication and travel impossible. Even civilizations that have spread across their home galaxy will find themselves cut off from other galaxies by distances that grow faster than any signal can cross. The Andromeda Galaxy is currently 2.5 million light-years away from the Milky Way, and the two are actually moving toward each other due to local gravitational attraction. They will merge in about 4.5 billion years. But beyond the local group of galaxies, the expansion of the universe is carrying everything away. The Virgo cluster, the nearest large galaxy cluster, is being carried away from us at a speed that will eventually exceed any conceivable interstellar travel speed. Galaxies beyond the Virgo cluster are receding so fast that they are already, in many cases, beyond our cosmic horizon. Light from them, emitted now, will never reach us. They are gone. From any sufficiently distant future perspective, the observable universe will shrink. Civilizations that exist 1 trillion years from now will look up at a sky that is much darker than ours. Most of the galaxies we see today will have moved beyond the cosmic horizon and become unreachable, unobservable. The universe will appear to be a single isolated galaxy floating in an infinite dark. A civilization in that era would have no way to know that the universe was once filled with galaxies. The evidence of the larger cosmos will have been carried beyond their reach by expansion. They would have only their own galaxy. And eventually, even their own galaxy would dim as its stars burned out and were not replaced. This is the final isolation, not isolation from each other within the galaxy. isolation from the universe itself. And it operates as a filter in its own way. Civilizations in the late universe have access to less, can observe less, can do less than civilizations in the early universe. The window during which interstellar civilization is possible at all may be closing. We are not necessarily early in cosmic history. We may be at the tail end of the era when civilization is even worthwhile. This raises a question that has been hovering at the edge of this discussion, the question of timing. If civilizations are doomed to disappear, when in cosmic history is the best moment to try? When are the conditions most favorable for a civilization to survive longest? The answer is not what you might expect. The conditions for intelligent life are not constant across cosmic history. The early universe was too hot and dense for stable planets. The first generation of stars contained almost no heavy elements, because heavy elements are forged in stars and require multiple generations of stellar death to accumulate. Planets like Earth, rich in carbon and oxygen and iron, could only form after the universe had recycled its material through several generations of stars. The first habitable planets probably did not appear until the universe was several billion years old. After that, conditions were favorable for several billion years. Stars formed at high rates. Planets formed in stable orbits. Heavy elements were abundant. Civilizations had time to evolve. We are in the late part of this favorable window. The peak rate of star formation in the galaxy occurred about 10 billion years ago and has been declining ever since. The pool of available planet-forming material is shrinking. Future civilizations that arise after us, will have fewer resources to work with. The galactic habitable zone is also shifting. Stars that are too close to the galactic center are bombarded by radiation from the central black hole and from the dense cluster of stars around it. Stars too far from the galactic center are in regions of low metallicity, where the heavy elements needed for rocky planets are scarce. The sweet spot, the band of the galaxy where conditions are most favorable for habitable planets, is a relatively narrow ring. Earth happens to be near the inner edge of this ring. As the galaxy continues to evolve and as star formation moves outward, the habitable zone will gradually shift outward as well. We are in a good position now. We will not always be. The conditions that produced us are not permanent. They are a temporary configuration in the galaxy's long evolution, and they will fade. This means the Great Filter, broadly understood, includes not just the threats that civilizations face during their lifetimes, but the conditions of the universe at the moment they arise. A civilization that arises in a star system at the wrong time, in the wrong place, in the wrong generation of stars, may face challenges that no amount of intelligence can overcome. The cosmos has windows. Civilizations have to arise within those windows, and the windows are not staying open forever. So where does this leave us? We have surveyed the filters. We have looked at the mechanisms by which civilizations disappear. We have considered the cosmic threats, the biological vulnerabilities, the technological dangers, the thermodynamic limits, the expansion of the universe, the shifting conditions of the galaxy. And the picture that emerges is bleak in its specificity. Civilizations face hundreds of distinct ways to fail. Most of those ways have probability greater than 0%. The cumulative probability of failure over the timescales required for galactic visibility approaches 1. The math says that civilizations should be rare in the galaxy at any given moment. The observations confirm the math. We hear nothing. We see nothing. The cosmos is quiet because the filters are working as expected. The civilizations that have arisen have, almost all of them, gone dark. And here we are. One civilization in one star system on one planet that has been doing this for less than a single century of detectable radio emissions. The odds say we should not make it. The odds say that within a few centuries we too will go quiet, leaving nothing behind but a thin chemical signature in our planet's geology that will be indistinguishable from natural processes within a few million years. The universe will not remember us. The galaxy will not notice when we stop transmitting. Whatever brief flicker we have made in the cosmic dark will fade, and the silence will continue. This is the default outcome. This is what the data predict. Anything else requires us to do something that no civilization has apparently ever done. To survive the technological transition, to navigate every filter, to persist beyond the brief window of detectable adolescence and become something more durable. And nothing in our history suggests we are particularly equipped to do this. But there is a counterargument. There is a reason to think that the default outcome is not inevitable. And it comes from the very thing that makes us vulnerable: our awareness of the problem. Every civilization that has collapsed on Earth collapsed without seeing the collapse coming. The Romans did not know they were Romans in decline. The Maya did not know they were the last generation of their high civilization. The Anasazi did not know their cities would be abandoned within a generation. Collapse is invisible from inside. The pattern only becomes clear in retrospect. But we have something those civilizations did not have. We have history. We can look back at the previous collapses and trace the chains of cause and effect that destroyed them. We can identify the structural weaknesses that they did not see in themselves. We can model the trajectories that lead to collapse and the trajectories that might lead to survival. This is unprecedented. No civilization before us had this perspective. We are the first species that has the capacity to study its own potential extinction in advance and try to prevent it. Whether that capacity translates into actual prevention is another question. Knowledge is not action. Awareness is not change. We may know exactly what is wrong with our trajectory and still be unable to alter it. The political and economic systems that produce the trajectory may be more powerful than any individual's awareness. The challenges may be too large. The coordination required may be impossible. We may know we are headed toward a cliff and still walk over it. But the possibility of doing otherwise exists, and that possibility, however slim, is something. It is a thread of hope in a dark calculation. It is the reason the great filter may not be deterministic. The filter is severe. The filter is reliable. But the filter is not inevitable. Some civilizations in principle can navigate it. The question is whether we will be among them. To do that, we would have to do things that no human civilization has ever done. We would have to coordinate at a planetary scale, on time horizons measured in centuries. We would have to develop institutions capable of managing technologies whose consequences play out over generations. We would have to constrain our worst impulses while preserving our capacity for innovation. We would have to balance competing demands of present and future, of growth and sustainability, of freedom and coordination, in ways that no political system has ever managed. We would have to do all of this while continuing to develop technologies that grow more powerful and more dangerous every year. The challenge is staggering. And yet, it is not impossible. The challenge is not against the laws of physics. It is against the limits of human nature. And human nature, while it has limits, also has capacities that we are still discovering. Humans built democratic institutions. Humans built international cooperation. Humans built scientific communities that span the globe and produce knowledge through processes no individual could replicate. Humans built systems for managing nuclear weapons that have, so far, prevented the worst from happening. These are remarkable achievements. They are not enough on their own, but they are evidence that humans can do hard things when the alternative is unbearable. The question is whether we can do harder things, whether we can extend our cooperative capacities to encompass risks we have not yet faced, whether we can develop the institutional immune systems that previous civilizations lacked. The answer is unknown. The experiment is in progress. We will find out, probably within this century, whether the species that recognize the Great Filter can be the species that crosses it. There is something almost vertiginous about contemplating this moment. The first 500 years of human civilization were lived without any awareness of the cosmic context. The Sumerians and Egyptians and Greeks and Romans built their civilizations without knowing what a galaxy was. They built without knowing that other suns existed. They built without knowing the age of the universe, the scale of cosmic time, the patterns of stellar evolution, the laws of thermodynamics. They worked entirely within their own perception, and they collapsed entirely within their own perception. Their failures were local. Their successes were local. The cosmos was a backdrop, not a context. We are different. We know what the cosmos is. We know what the filters are. We know what is at stake. The decisions we make in the next century are decisions made with knowledge of the cosmic context. We are the first civilization on this planet, and possibly one of the first in the galaxy, to choose its trajectory while understanding what is at stake. This may be the most important fact about our species. It is also the most fragile. The understanding could disappear. The next major crisis could destroy the institutions that preserve cosmic knowledge. The retreat into immediate concerns, into survival, into local politics, could erase the broader perspective that took millennia to develop. We are temporary stewards of an awareness that no previous generation possessed, and no future generation is guaranteed. What we do with that awareness is the test. Let us consider what it would actually look like to pass the test. What does a civilization that survives the Great Filter actually become? The first thing it would have to do is solve its existential risks. It would have to find ways to make nuclear weapons impossible to use catastrophically, perhaps by reducing arsenals to levels below the threshold of civilizational collapse, perhaps by developing defensive technologies that neutralize them. It would have to manage biotechnology in ways that prevent engineered pandemics, perhaps by limiting access to dangerous capabilities, perhaps by developing biological countermeasures faster than threats can emerge. It would have to navigate the development of artificial intelligence in ways that produce systems aligned with human values rather than indifferent to them. It would have to manage its climate, transition to sustainable energy, restore degraded ecosystems, stabilize its population. It would have to develop the political and economic institutions capable of doing all of this simultaneously over timescales of centuries. The civilization that emerges from successfully doing all of this would not look like our current civilization. It would be fundamentally different. Its values would have evolved, its institutions would have evolved, its technology would have evolved. The relationships between humans and machines, between humans and ecosystems, between humans and each other would all be transformed. It would still be us in some sense, but it would not be the us we are now. It would be the us we have become through the trial of the filter. And then, having survived all of that, the civilization would have to face the next set of challenges. The cosmic challenges. The gradual aging of the sun. The eventual need to leave Earth either by moving the planet or by colonizing other star systems. The construction of habitats that can sustain life independent of any single planetary environment. The development of propulsion systems capable of reaching other stars in timescales that biological beings can survive. The establishment of redundant populations on multiple worlds, so that no single catastrophe can extinguish the species. The very long-term challenges of operating across interstellar distances where light speed limits make rapid coordination impossible. Each of these is a major undertaking. Each of them probably requires capabilities we do not yet possess. And the civilization that takes them on must remain coherent across timescales of thousands or millions of years, which no human civilization has ever managed. The challenges escalate. The filters continue. The Great Filter is not a single barrier, but a sequence of barriers, each more difficult than the last. To become a galaxy-spanning civilization, a species has to pass through all of them. The math says almost no species does. But math is not destiny. Math is probability. And probability allows for outliers. Somewhere in the galaxy, at some point in cosmic history, there may have been outliers. Civilizations that beat the odds, that found their way through the filters, that persisted long enough to become something extraordinary. We do not see them, but they may exist. Or they may exist in forms we cannot recognize. Or they may have come and gone before we evolved to ask the question. We do not know. What we do know is that we are here now. The conditions that allowed us to arise are present. The window during which our civilization can become detectable is open. We are inside the brief flicker that, for most civilizations in the galaxy, is all they ever achieve. The question is what we do with this flicker. Whether we extinguish ourselves quickly, joining the long list of vanished civilizations whose remains will be invisible to any future observer. Whether we transform into something post-biological that no longer participates in the cosmic conversation, becoming silent not through extinction, but through transcendence. Whether we somehow find our way through all of the filters and persist long enough to leave a mark on the galaxy that lasts beyond a few centuries. The default is silence. The default is disappearance. The default is the same outcome that has apparently happened to every other civilization the galaxy has ever produced. We have to do something extraordinary to be different. And there is no template for the extraordinary thing we have to do. No civilization has done it. No predecessor has left us instructions. We are inventing the path as we walk it. The work is unprecedented, the stakes are total, and the moment is now. But before we can do anything extraordinary, we have to face a quieter possibility. A possibility that does not involve catastrophe at all. A possibility that may be the most common fate of civilizations in the galaxy and the most difficult to recognize from the inside. It is the possibility of simply giving up, not through war, not through collapse, not through any dramatic event that would leave an imprint on the cosmic record, through fatigue, through loss of interest, through the slow dissolution of the collective will to maintain a civilization across time. Consider what it actually takes to maintain a technological civilization. It takes generations of children who grow up willing to do difficult work to keep the systems running. It takes researchers willing to spend decades pursuing problems whose solutions may not arrive in their lifetimes. It takes builders willing to construct infrastructure that they may not live to see completed. It takes administrators willing to make decisions whose consequences will play out over centuries. Every functioning civilization runs on a substrate of human investment that extends across generations, and that investment is not guaranteed. It depends on a sense of purpose, on a belief that the project of civilization is worth continuing, on a willingness to subordinate immediate comfort to long-term goals. When that belief erodes, civilizations begin to decay, even without any external pressure. The buildings still stand, the systems still operate, but the next generation is less interested in maintaining them. The generation after that, less still. Eventually, the systems begin to fail, because nobody is willing to do the work of keeping them running. And this is not hypothetical. This pattern has appeared in human history. The decline of the Roman Empire was not just military or economic. It was psychological. The Romans of the late empire were less willing to serve in their own armies, less willing to take public office, less willing to invest in the institutions that had built the empire. They wanted the benefits without the labor. The empire could not run on autopilot. When the willingness to maintain it faded, the empire faded. Now apply this to alien civilizations. Apply it to every species that has reached a level of comfort where survival no longer requires constant effort. There is a real question about whether civilizations can sustain themselves once they no longer need to. Once the existential pressures that built them recede, the energy that maintains them may also recede. Some researchers have proposed this as a major factor in the Great Filter. Not collapse, but lassitude. Not extinction, but exhaustion. The civilization simply stops bothering. The members continue to exist as individuals, but they no longer participate in the collective project. They drift into private pleasures, private concerns, private worlds. The civilization fades, not because it failed, but because nobody could be bothered to continue it. And from a distance, this looks the same as catastrophic collapse. The radio emissions cease, the orbital activity diminishes, the technological signature weakens. The civilization is gone, even though the species may still exist. This may be one of the most insidious filters of all. Because it is invisible from inside, every individual in the civilization may be doing perfectly reasonable things, pursuing perfectly reasonable goals. Nobody is acting destructively. Nobody is making a catastrophic decision. The civilization just slowly stops being a civilization. It becomes a collection of individuals on a planet, no longer engaged in any shared project, no longer maintaining the infrastructure that made them visible to the cosmos, and then they fade. There is a related possibility that is even stranger. The possibility that civilizations transform themselves into forms that we cannot recognize as civilizations at all. We assume that an advanced civilization would build megastructures, broadcast signals, send probes, leave detectable evidence of its existence. But this assumption may be parochial. It may reflect our particular biological psychology, our particular evolutionary inheritance, our particular moment in cosmic history. A civilization a million years more advanced than ours may not want any of those things. It may have abandoned the goals that we assume are universal. It may have transformed into something whose motivations are unrecognizable to us. The British physicist Freeman Dyson once speculated that advanced civilizations might disassemble their stars and reassemble them into structures called Dyson spheres, vast shells that capture all of the star's energy output for use by the civilization. We have searched for Dyson spheres. We have searched for the infrared signatures that they would emit. We have found nothing that clearly fits. But what if Dyson was wrong? What if advanced civilizations have no interest in capturing all of their star's energy? What if their energy needs are far smaller than we assume, because they have found ways to do enormous amounts of computation with very little energy? What if they have miniaturized their existence to scales we cannot detect? The trend on Earth is towards smaller, more efficient computing. The first computers filled rooms. Modern computers fit in pockets. A computer 1,000 times more powerful than today's may fit in something smaller than a grain of sand and consume less power than a candle. Extrapolate that for 1,000,000 years. The descendants of any technological civilization may exist as essentially invisible patterns of computation operating at scales that no telescope can resolve. They are there. They are conscious. They are pursuing whatever goals they have. But from across the galaxy, they are indistinguishable from background noise. The civilization persists, but its persistence is not detectable. It has become a quiet observer of the cosmos, rather than a loud participant in it. And there is something almost beautiful about this possibility. The idea that the most advanced civilizations in the galaxy are not the ones building the loudest megastructures, but the ones that have learned to do more with less. To exist gracefully rather than expansively. To compute and create and explore without leaving a trail of evidence across the sky. They are the masters of efficiency, the poets of restraint, and we, with our radio towers blasting incoherent signals in every direction, are the awkward adolescents, shouting into a room of quiet sophisticates who have long since stopped shouting. There is yet another possibility we have not fully explored. The possibility that civilizations stop transmitting not because they have transformed, but because they have learned something we have not. They have learned that transmitting is dangerous. This is the dark forest hypothesis, popularized by the Chinese science fiction author Liu Cixin, but grounded in real principles of game theory. The argument is simple. In a galaxy where multiple civilizations exist, but cannot reliably assess each other's intentions, the safest strategy is to remain hidden. Any civilization that broadcasts its existence risks being targeted by a more powerful or more paranoid neighbor. The civilizations that survive are the ones that learn to be silent. The civilizations that broadcast are the ones that get destroyed. Over time, the galaxy is filled only with silent civilizations, listening, watching, hiding. The dark forest hypothesis has problems. It requires every civilization to independently arrive at the same paranoid conclusion. It requires that interstellar weapons are practical and accurate enough to make hiding worthwhile. It requires that no civilization ever defects from the silence and becomes a loud anomaly. But the hypothesis cannot be dismissed entirely. There is no evidence against it. There is only the silence itself, which is consistent with what the hypothesis predicts. If the dark forest is real, then our current behavior, transmitting radio signals into space, is potentially suicidal. We are advertising our position to whatever predators may be listening. The fact that nothing has happened to us yet may mean that we are too young to have been noticed, or that the predators are too distant to have arrived, or simply that the hypothesis is wrong. But it may also mean that we are being watched, that a decision is being made, that our brief flicker of radio transmissions has registered in some distant detector and a calculation is underway about what to do with us. This is paranoid thinking. It is also not unreasonable. The history of contact between technologically uneven civilizations on Earth is not encouraging. Every time a more advanced civilization has encountered a less advanced one, the less advanced one has typically been devastated. The native populations of the Americas, the Aboriginal peoples of Australia, the cultures of sub-Saharan Africa. The encounter was not a meeting of equals, it was a takeover. And these were all members of the same species. Imagine the encounter between civilizations separated by millions of years of independent evolution, with values and goals that may have no overlap with ours. The encounter might not be hostile, but it might not be safe either. And the safest strategy, from our perspective, may be to keep listening but stop broadcasting. To remain hidden until we have a better sense of what we are hiding from. To treat the galaxy as the dark forest it may turn out to be. Most researchers do not take the dark forest hypothesis seriously enough to recommend operational silence. The benefits of radio communication on Earth far outweigh the speculative risks of detection by alien civilizations that may or may not exist. But the hypothesis exists. It is on the menu of possibilities, and it suggests that the silence of the galaxy may not be evidence of empty space, but evidence of wisdom we have not yet acquired. There is one more possibility that deserves attention. It is the simplest of all, and perhaps the most uncomfortable. The possibility that we are alone. Not because the filters have killed everyone else. Because nobody else ever arose. The probability of life arising from non-life is unknown. The probability of intelligence arising from life is unknown. The probability of technological civilization arising from intelligence is unknown. We have a sample size of 1 for each of these transitions. We cannot estimate the actual probabilities from a single data point. It is possible that the transitions are common and the galaxy was once full of life. It is also possible that the transitions are extraordinarily rare, and we are an outlier of such magnitude that we may be the only one. If the origin of life requires a specific combination of conditions that is exceedingly rare, then life may have arisen only a handful of times in the entire history of the galaxy. If intelligence requires another rare combination, then intelligence may have arisen even fewer times. If technological civilization requires yet another, then we may be the only one that ever has. The galaxy is silent because there is nobody to make noise. The cosmos is empty in the sense that matters most. We are alone. This possibility is, in some ways, more devastating than the Great Filter possibility. The Great Filter at least implies that the universe has produced intelligence many times. We are one of many failed experiments, but the experiments themselves were real. If we are alone, then the universe has produced intelligence exactly once, and it is us, and our extinction would mean the end of consciousness in the cosmos. Forever. No backups. No second chances. The universe would continue, but it would no longer contain anything that could comprehend itself. The lights of awareness would go out, and they would not come back on, because the conditions that produced them in the first place are too rare to be repeated within any reasonable time frame. The weight of this possibility is enormous. If we are alone, then our survival is not just our concern. It is the concern of the entire cosmos. We are the universe's only chance to know itself, to be aware of itself, to find meaning in its own existence. And if we extinguish ourselves, that chance is gone. The universe returns to mindless processes, unfolding for trillions of years toward heat death, with no observer to witness any of it. Whether the galaxy is full of vanished civilizations, or whether we are alone, the result for us is the same. We are the only intelligence we have evidence of. We are the only consciousness we can study. We are the only project of civilization we can affect. The decisions we make in the next century will determine whether this experiment continues or whether it ends. And no one is going to make those decisions for us. There is no senior civilization that will swoop in to save us. There is no benevolent observer that will intervene if we get too close to disaster. There may not even be any other observers at all. We are it. We are the entire cast of this drama. And we have to write our own ending. The cosmic context that we now possess is both a gift and a burden. The gift is that we understand what is at stake. We can see the filters, we can identify the risks, we can plan responses with knowledge that no previous generation possessed. The burden is that we cannot pretend ignorance anymore. We cannot tell ourselves that someone else will handle it. We cannot defer to gods or to history or to the natural course of events. We are the natural course of events. Whatever happens to civilization happens because we did or did not do something specific. Whatever happens to consciousness on this planet happens because we either preserved it or did not. The responsibility is total. The decisions are immediate. The window of opportunity is shrinking. What does it mean to live with this awareness? The honest answer is that nobody knows. No previous generation has lived with this knowledge. The philosophical and psychological frameworks we have inherited from our ancestors were not designed to accommodate the cosmic perspective. The religions of the world developed in eras when the universe was assumed to be small and human-centered. The political ideologies of the modern era developed in periods when civilizational collapse was either ignored or treated as someone else's problem. The economic theories that govern our current decisions were developed assuming that growth was endless and resources were effectively unlimited. None of these frameworks is fully adequate to the situation we are in. We are improvising. We are inventing new ways of thinking about meaning, value, time, responsibility in real time while the clock runs. Some people respond to this by retreating into denial. They choose to ignore the cosmic context and focus on immediate concerns. There is a kind of mental relief in this. The problems are too large to think about, so we do not think about them. We live our lives at human scale, attending to our families and our work and our personal projects, and we let the larger questions go. This is a coherent response. It is not necessarily wrong. The cosmic context is genuinely overwhelming. Humans are not built to carry it constantly, but it is also a response that, if universal, guarantees the default outcome. If everyone retreats from the cosmic perspective, nobody is working on the cosmic problems. The filters operate unchecked. The civilization fails by inaction. Other people respond by becoming consumed. They take on the weight of the entire cosmic project and find themselves unable to function. The scale of the problem is so vast that any individual effort seems pointless. The despair is paralyzing. This response is also coherent. The problems really are vast. Individual effort really is small relative to them. But this response also guarantees failure, because despair produces nothing. The civilization needs people who are working on the problems, not people who are immobilized by them. The challenge is to find a middle path, to take the cosmic context seriously without being destroyed by it, to recognize the scale of the problems without losing the capacity to act on them, to live human-scale lives while contributing what we can to the larger project, to be ordinary people doing ordinary things while remembering that the ordinary things are part of an extraordinary effort. This middle path is not natural. It requires deliberate cultivation. It requires institutions and communities that hold the cosmic perspective on behalf of their members, so that no individual has to carry it alone. It requires practices and habits that translate the abstract awareness into concrete daily action. We are in the early stages of building these institutions and practices. The work is incomplete. But it is happening. There is something to be said for the simple fact that we know, even if we fail, even if we join the long list of vanished civilizations, whose remains will be invisible to any future observer. We knew. We saw the filter. We named it. We tried. That itself is something the universe has produced. A species that recognized its own probable fate and attempted to avoid it. Whether the attempt succeeds is uncertain. But the attempt is real. It is happening. And the fact that it is happening means that consciousness has done something on this planet that, as far as we can tell, has not been done many times before. It has turned the cosmic mirror on itself. It has looked at the universe and seen, in the universe, its own face. And it has tried, however clumsily, to take responsibility for what comes next. If we fail, we will not be remembered. The cosmos will not mourn us. The galaxy will not pause to mark our passing. But we will have done something. We will have, in the brief moment of our existence, become aware of what we were. And that awareness is itself a kind of victory. A small one, a vanishing one, but a real one. The universe contained, for a moment, a species that knew what it was doing. That is not nothing, even if it is not enough, even if it is the last thing the universe ever contained. So this is where we end, not with a prediction, not with a prescription, with a question. The galaxy has produced thousands or millions of civilizations across its long history. Almost all of them have disappeared. Some were destroyed by their own technology. Some collapsed under their own complexity. Some were eliminated by cosmic events. Some transformed into forms we cannot detect. Some simply faded out of fatigue or disinterest. The mechanisms vary. The result does not. The lights go out. The signals stop. The civilization becomes invisible. And the silence that fills the galaxy is the cumulative silence of all those vanished worlds. We are one more candle in this immense dark. We are burning now. We are visible now. We are broadcasting now. How long that lasts is up to us. There is no script. There is no template. There is no guarantee. The universe does not promise us survival. The galaxy does not reward intelligence. The cosmos is patient and indifferent, and it will outlast everything we build, including ourselves. But for this brief moment, we exist. We are aware. We are doing things. We are making choices. The choices we make do not determine the fate of the universe. The universe will be fine. The choices determine our fate. Our small, particular, locally significant fate. And the choices are real. They matter. They are happening now, in this century, in our lifetimes, in our actions. The Great Filter is not an abstraction. It is a set of specific decisions we are making about specific technologies and specific institutions and specific behaviors. We can affect those decisions. We can influence them. We can make the difference between the civilization that disappears and the civilization that endures. Whether we do or not is not predetermined. It is a function of what we collectively choose to do. Some readers will find this conclusion frustrating. They will want certainty. They will want a definitive answer to the question of whether we will make it. There is no such answer. The question is genuinely open. The data does not support optimism, but it also does not foreclose hope. The math says we should fail. The history of every previous civilization says we should fail. The pattern of cosmic silence says we should fail. And yet we are still here. We are still trying. We are still adding to the project of civilization, generation by generation, decision by decision. Maybe we will be different. Maybe we will be the first. Maybe in a galaxy where almost every candle has gone out, ours will be the one that finds a way to keep burning. Or maybe not. Maybe we will follow the same trajectory as everyone else and disappear into the same silence. The universe will not care either way. But we should care, because we are the ones who have to live through it. We are the ones whose lives, whose children's lives, whose great-grandchildren's lives depend on the outcome. The cosmic stakes are abstract. The human stakes are immediate. And the human stakes are sufficient reason to try. The disappearance of civilizations is not just a cosmological problem. It is a moral problem. It is a problem about what we owe to the future. We did not choose to be born into this moment. We did not choose to be the generation that has to confront the Great Filter directly. We could complain that the responsibility is unfair, that we should not have to bear it, that it should have fallen on a different generation more equipped to handle it. But it did not. It fell on us. And the choices about how to respond are ours. We can defer the problem to our children. They will then defer it to theirs. At some point, the deferral runs out. At some point, a generation has to do the work. That generation may be us. Or it may be a generation that comes later that inherits a worse situation than we did because we did not act. Either way, the bill comes due. The filter does not negotiate. It does not give extensions. It operates on its own schedule, indifferent to our preferences. So we work, we try, we act with whatever capacity we have, knowing that our individual contributions are small, but that the cumulative effect of many small contributions can be substantial. We do not need to save the world by ourselves. We need to be part of a larger project that saves the world together. That project is happening. There are scientists working on existential risks. There are policymakers working on international coordination. There are entrepreneurs working on sustainable technologies. There are educators teaching the cosmic context to the next generation. There are writers and filmmakers translating the abstract problems into emotional reality so that more people can engage with them. None of these efforts is sufficient on its own. All of them together may be enough. The question is whether the cumulative effort can scale fast enough to address the cumulative risk. The race is real. The clock is running. And the outcome is not yet written. When we look at the night sky, we are looking at a graveyard. In some sense, the stars themselves will live billions more years. But the civilizations that may have arisen around those stars, those civilizations have probably already lived and died. The light we see is older than them. It has traveled for thousands or millions of years across the dark. It comes from worlds where intelligence may have flourished and then disappeared, leaving no trace except the faint chemical fingerprints in the rocks that we will never be able to read from this distance. Every point of light in the sky is a candle that may have burned, briefly, and then gone out. And we cannot know which ones. We cannot know how many, we cannot know what they were. The galaxy holds its secrets. The dead civilizations do not introduce themselves. They simply leave us alone in a sky that looks full but is functionally empty, populated by ghosts of intelligence that no instrument can detect. This is the reality. This is what we live with. The cosmos is haunted by what has come before us, and we cannot know whether we will join the haunting or whether we will somehow escape it. The honest answer is that we probably will not escape it. The honest answer is that we probably will join the long line of civilizations that flickered briefly and then went silent. The honest answer is that the Great Filter has destroyed every previous attempt, and there is no compelling reason to think it will spare us. But the honest answer is also that we do not have to accept the honest answer. We can try to be different. We can try to be the exception. We can try to do what no civilization has apparently ever done, which is to navigate the filter consciously, deliberately, with eyes open and full knowledge of what is at stake. Whether the attempt succeeds is not the same question as whether the attempt is worth making. The attempt is worth making. It is worth making because the alternative is to give up, and giving up guarantees the worst outcome. It is worth making because the effort itself produces value, regardless of whether it ultimately succeeds. It is worth making because we are, as far as we can tell, the only ones who can make it. There is nobody else. There is just us. And we are running out of time. We began tonight with a moment that comes for every civilization, when the lights begin to dim, when the signals stop, when the silence sets in. That moment is real. It has come for every civilization that the galaxy has ever produced, with the possible exception of ours. And our moment is approaching. We cannot say exactly when it will arrive. We cannot say exactly what form it will take. But we can say that without significant change, our default trajectory leads to that moment within the next few centuries. Maybe sooner, maybe later. But within a window that is, by cosmic standards, immediate. The question that hovers over everything is whether we will become one more vanished civilization or whether we will become something the galaxy has not seen before. A civilization that recognized the filter and survived it. A civilization that found a way to persist beyond the brief window of detectable adolescence and become something durable. A civilization that left a mark on the cosmos that lasts longer than a flicker. The answer is not yet written. It is being written now by every decision we make about how to live, how to organize ourselves, how to manage our technologies, how to relate to our planet, how to think about the future. We are the authors. The page is in front of us. The cosmos is waiting to see what we do. Not because the cosmos cares, the cosmos does not care, but because the only audience that matters is us. The only readers of this story are the ones who will live through its outcome. We are the writers. We are the readers. We are the characters. And the ending depends entirely on what we choose. Every civilization in the galaxy is doomed to disappear. Every one. The math says so. The history of cosmic time says so. The silence we hear when we point our telescopes outward says so. But doom is a default, not a destiny. It is what happens if nothing else happens. It is the outcome of inaction, of distraction, of failure to coordinate, of failure to imagine. It is not the only possible outcome. The other outcomes are possible, but they are not guaranteed. They have to be earned. They have to be built. They have to be defended against the constant pressure of the filters that destroy everyone who is not paying attention. We are, perhaps for the first time in our history as a species, paying attention. We see the filters. We name them. We talk about them. We design responses to them. Whether the responses are adequate is uncertain. But the attention itself is unprecedented, and it is the precondition for everything else. Without the attention, the responses do not happen. Without the responses, the filters operate unchecked. Without an unchecked response, the civilization joins the others in the long silence. The attention is the beginning. What we do with the attention is the rest. The cosmic perspective demands a great deal of us. It demands that we think on timescales we are not biologically equipped to think on. It demands that we coordinate at scales we have never managed before. It demands that we constrain our worst impulses while preserving our creative capacities. It demands that we become wiser than any previous generation of humans has ever been. It is a tall order. It is possibly an impossible order. but it is the order that has been placed in front of us. And the alternative is to disappear, like every civilization before us, into a silence that will not even register on the cosmic record. So we work, we try. We do what we can with the time we have. We are aware of the filter. We are aware of the stakes. And we are still here. The flame is still burning. Whatever comes next is up to us. Thank you for spending this time with us. If this exploration moved you, share it with someone who needs to hear it, and subscribe to Hidden Beyond Stars for more journeys into the questions that matter most. The galaxy is quiet. But for now, in this brief moment, on this small blue world, we are still loud, we are still here, and we are still trying. And there is something worth pausing on before we close. Something about the strangeness of being in this position at all. Consider the chain of events that had to occur for you to be listening to this. The universe had to form. Matter had to condense into stars. Stars had to forge the heavy elements in their cores and scatter them into space when they died. A second generation of stars had to form from those enriched clouds, and one of them, our sun, had to assemble a system of planets around it. One of those planets had to settle into an orbit at exactly the right distance to allow liquid water on its surface. That planet had to be struck by a Mars-sized object early in its history, producing a moon large enough to stabilize the planet's axial tilt. The planet had to develop plate tectonics, which regulate the carbon cycle and keep the climate within a habitable range for billions of years. Life had to arise on that planet against odds we cannot calculate. Life had to survive multiple mass extinction events that erased most of the species that came before us. Intelligence had to emerge somehow from the long process of evolution that produced our specific lineage. Culture had to develop. Agriculture had to be invented. Writing had to be invented. Science had to be invented. Telescopes had to be built. Decades of patient observation had to accumulate. And finally, you had to be born into a moment of human history when the cosmic context has been pieced together enough that you can hear someone talk about the great filter and understand what is at stake. Every step in this chain was contingent. Every step could have failed. The fact that it did not fail, that the chain reached all the way from the Big Bang to your awareness of the Big Bang, is staggering. It is, as far as we know, what the universe was for, not in any teleological sense, not in any sense that implies purpose or design, but in the sense that this is what happened. This is what the universe produced. You, sitting here, thinking about what comes next. That is a real outcome of cosmic processes. It is not nothing. It is, in fact, an extraordinary something. And the question of whether the chain continues or breaks is now in our hands. The cosmos has handed us the next link in the chain and asked us to forge it, or to drop it, whichever we choose. The choice is real. The choice matters. The chain is unfinished. And the next century is when much of the next forging will happen, or fail to happen. Some of you listening will be tempted to feel small, to feel that nothing you do as an individual could possibly matter at the scale of cosmic civilization. To conclude that the Great Filter is too large a problem for any one person to affect, and that personal action is therefore pointless. This conclusion is wrong. Not philosophically wrong, mathematically wrong. Civilizations are not produced by single individuals. They are produced by the cumulative actions of billions of individuals over time. Every civilization that has ever existed was built by people who individually had only modest power, but who collectively transformed their worlds. Rome was not built by one person. Neither was the Maya civilization. Neither was modern industrial society. They were built by the small actions of many people, accumulated over generations. The same is true of civilizational survival. It will not be the achievement of any single individual. It will be the cumulative outcome of many individuals making many small decisions that, taken together, shift the trajectory of the species. Your decisions are part of that aggregate. They are not nothing. They are also not everything. They are one input into a vast collective process, and the process needs your input. It needs the input of everyone who is paying attention. The collective response to the Great Filter is built from individual responses, and the individual responses are made by individual people, including you. So the question is not whether your actions can save the world. They cannot. The question is whether your actions can contribute to the collective effort that may save the world. They can. They do. Every act of attention, every act of investment in long-term thinking, every act of resistance to the slow erosion of institutions and capacities, every act of contribution to the project of civilization matters. Not infinitely, not decisively, but measurably. The math is on your side. You are part of an enormous aggregate, and the aggregate is the thing that determines the outcome. There is one more thing to say before we end. The vanished civilizations of the galaxy, if they existed, did not know they were going to vanish. From the inside, they probably thought they would persist. They probably had ambitions that ran into deep time. They probably had cultural products they expected to last. They probably had names for themselves that they expected the universe to remember. And the universe did not remember. Their names are gone. Their cultural products are gone. Their ambitions are dust. We do not know what they called themselves, or what they believed, or what they made, or how they understood their own existence. The silence has consumed all of that. And the silence will consume us too, unless we do something very different from what every previous civilization has done. This is not a comforting thought, but it is a clarifying one. It strips away illusions. It forces us to confront the reality that we are, by default, on the same trajectory as everyone else. That, without conscious, deliberate effort, we will fade like they faded. That our names will be forgotten too, not by other civilizations, but by the cosmos itself, which does not remember anyone. The clarity is uncomfortable, but it is also liberating, because it means that what we do in this moment is not constrained by tradition or precedent. There is no precedent for what we have to do. No civilization has done it before. We are not bound by the patterns of the past. We are free to invent new patterns, free to build institutions that no civilization has ever built, free to think on timescales no civilization has ever sustained, free to attempt what no civilization has ever attempted. The freedom is terrifying. It is also the only freedom that matters, because it is the freedom to be different from the default, to be the exception to the rule, to find a way through where everyone else found a wall. The walls are real. The filter is real. The probability of failure is high. But the probability of success is not zero. And the only way to find out which side of the probability we land on is to try. So we try. We keep trying. We try across generations, across institutions, across the slow accumulation of knowledge and wisdom that is the only resource we have. We try with the recognition that trying may not be enough. We try anyway, because the alternative is to accept the default, and the default is the long silence that has consumed everyone before us. And maybe that is the real meaning of being conscious in a universe like this one. Not to escape death. Death is not escapable, neither for individuals nor for civilizations. Not to defeat entropy. Entropy is not defeatable. Not to find permanent meaning in a universe that may not have any. The meaning is not given. The meaning is made, locally, temporarily, by the conscious beings who choose to make it. And the meaning we make is not eternal. It will fade with us. But while we exist, while we are still here, while the flame is still burning, the meaning is real. It matters to us. It matters because we are the ones for whom it matters. There is no other audience. There is no cosmic observer keeping score. There is just us, and the choices we make, and the brief moment of awareness we have been given. We can spend that moment in distraction. We can spend it in despair. Or we can spend it doing what conscious beings, at their best, have always done. We can pay attention. We can take responsibility. We can act with care for the future, even knowing that the future is not guaranteed. We can be, in the time we have, the kind of beings the universe seems to have been working toward, even if the universe was not actually working toward anything. We can choose to be worthy of the chain of contingencies that produced us. That is enough. That has to be enough. It is all we have. The galaxy is quiet because almost everyone before us failed. But we are not them. We are the ones who are still here. We are the ones who are aware of the silence and what it means. We are the ones who get to decide what comes next. There is no script. There is no template. There is no one to ask. There is just the work in front of us, and the awareness that the work matters, and the willingness, if we have it, to do the work even when it is hard. The flame is small. The dark is vast. But the flame is here. And as long as it is here, the story is not over. The next sentence is ours to write. So write it. Whatever you do tomorrow, whatever decisions you make in the years ahead, write your next sentence with the awareness that you are part of something the universe rarely produces. A civilization that has not yet failed. A civilization that still has a chance. A civilization whose ending is not yet written. From all of us here at Hidden Beyond Stars, thank you for listening. We will see you in the next journey into the dark.